A very good day. We will briefly present the Dorsal hand-based authentication system using AlexNet transfer learning, and they should be calculate the virtual authentication. As knows that fingerprint can be forgotten or easily cracked. Normally, fingerprint is a commonly used authentication system but in fact, fingerprint can be produced by using a Latin mold to fool the fingerprint sensor. On the other hand, face recognition is affected by the sight of tooth to be captured, while iris recognition is affected by brightness of the surroundings. Dorsal handprint, which is beneath the skin, has direct liveness detection. Its internal features make it highly difficult to be forged, and hence it is highly secure, and it's not affected by the external conditions such as dirt or the skin disease, which decrease the brain pattern readability. Sight is unique, universal, reliable, consistent, hence make it a suitable candidate to be used in authentication system. Convolution neural network is actually a type of deep neural network. It consists of the input layer. In this case, this is a Dorsal handprint. As an input, in the input layer, and then you have the convolution layers, which extract the features. Next layer is normally between the convolution layer. To pick the maximum value from a selected region and reduce the features dimensions, while the fully connected layer are placed in the last block of the CNN to connect with previous layer activities. And lastly, we have an output layer to predict the output losses. CNN actually combines both feature extraction and classification in one deep neural network. Hence, we no need to manually extract the features or select the significant features to be fit into the machine learning techniques. So it is easy compared to previous machine learning techniques. We are extracting the input layer, convolution layer, max layer, activation functions. Exactly to introduce the nonlinear property to the network. These are some common activation functions: sigmoid, tanh, value, softmax. This is a graph of level. This is a softmax. Basically, we have three types of CNN. First is designed from scratch. However, if designed from scratch, it needs huge data set, huge computation times, and long time computation power and longer time to train. The second one is used to pre-train models such as AlexNet, GoogleNet, VGGNet, DenseNet, SqueezeNet, ResNet, and so on. However, the pre-trained model can classify the pre-trained classes only. The third one is use of transfer learning. Transfer the learning from the pre-trained model. So you can have a limited data set problem, and all the weight that have been trained in the pre-trained model can be transferred to classify a new type of application technique. AlexNet chosen in this study because it has the least computation time and reasonable accuracy. AlexNet basically has 25 layers as shown in table 1 here. Start from the input layer, then the output layer, FC6, FC7, FC8 are the fully connected layers, and basically it has 5 event blocks of combination 1, 2, 3, 4, 5. In between the combination layer, you have a below normalizations, excluding, and so on. The scenes will be viewed in table 1 here. Once the objective of this study is to develop the Dorsal handling authentication system using transfer learning from AlexNet and to evaluate the performance of the developed system. This study consists of 2 phases, which is the enrollment phase and authentication phase. Each phase start from image acquisition, image resizing, and classification. And then at the end of the classification stage in the enrollment phase, the CNN model or the AlexNet model was saved to be used to predict in the authentication phase where a user wants to enroll to the authentication system. So the saved mirror word will be used to do the classification whether it is matched with the method has been saved. In case, then we'll display the GPU user with the glasses. Else we display the imposters. And then we'll do the evaluation of the performance of this authentication system. Then for the first stage which is image acquisitions, the image was acquired from Dorsal template database, which consists of 100 users left-in image under 4 different conditions, which is normal condition. The second one is after 1 minute of holding a 3 kg bags. The third one is after squeezing an elastic ball for 1 minute. The fourth condition is pulling the pen by holding the air pack on the back of pen. And then each condition has 3 images per user. So total we have 1,200 because each user will have 12 images. So total is 1,020 images. And then for the training or the enrollment phase, we will use 80 users only for the GPU or registered user, while user 81 to 100 was treated as an imposter or unregistered user. So for training phase, 12 images per 80 user or a total of 960 images were used. So from these 960 images, it was divided into 80% training and 20% validation, which is equivalent to 10 images for training, 2 images for validations. And then for the second stage, the image will reside from the original site 300x340 to 227x7 to fit the requirement of the AlexNet. And then for classification, we use the transfer learning from AlexNet, adapted in MATLAB 2020B, where the transfer learning is actually we call the AlexNet, the train network. And then this is just to review the network's architecture. And then we modify at layer 23. Initially, AlexNet is used to classify 100 classes. But for this application, we would like to classify 80 registered users. So 1000 was changed to 80 and connect back the last layer to classification layers. And we use the SGTM training method. Initial learning rate was set to 0.001. Meaning back site Okay, 128 was used, and used a 42 maximum code. Simulation was run using the Intel Arc Core i7 257 used 2 gig with 16 gigabyte RAM. Okay, and the authentication system was built using AlexNet guide. Okay, and the performance was evaluated using the confusion matrix, where the row represents the system, whether accept or reject. The column represents this is a real user or registered user. This is imposter or unregistered user. So if a real user or if a genuine user was accepted by the system, so this is true accepted. If an imposter was rejected by the system, so this is a true rejection. Okay, if an imposter was accepted by the system, so this is a full accepted false acceptance. And then if a genuine user was rejected by the system, so this is a full rejection, false rejection. And then the acceptance restriction is calculated by TA by the rows, the sum of the row, which is TA plus FA. Rejection restriction is a true PR divided by the sum of the row, PR plus FR. Okay, sensitivity or recall is a TA divided by the column sum of the column, which is TA plus FR. Specificity is a true PR, true rejection divided by FA plus TR. Accuracy is a TA plus TR divided by all the sum. Okay, and for the training result, 9.2% accuracy at the training stage was obtained. Okay, equal exactly one forward pass to calculate the loss function and one back propagation to update the weight to minimize the loss function. Okay, while iteration is actually one step to minimize the loss function using the mini batch size. So each equal may has many iterations. So in this case, training result, we see that at equal 9, we have a total of 50 iterations. And it took for this system, it took 1 hour, 50 minutes, 5 seconds to get this result. Actually, arrived at 100% and it reduced to 99.22%. Okay, for validations, we obtain 95 validation accuracy. You can see that we have 8 misclassification and off diagonal. Okay, and since each image, each classes 2 images during validation stage, once we have 8 misclassification, so the accuracy is calculated as 152 divided by 160 times 100%. This will get 95% validation accuracy. Okay, and for authentication result, okay, left figure shows that we have the our authentication system. So when you click the browse, the user selects the image to view and go to the system. Okay, for example, user choose this one, P1 underscore left underscore ACT-2 PMP. P1 stand for this is a user one, left hand image, okay, under the activity, okay, image number 2, file. And then once they click the evaluate, so the image will be classified using the same AlexNet model. Okay, in this case, it is correctly identified as user number 1. Okay, well, the second thing, the right hand figure shows that this is from image user P100 show from user 100. So once you click evaluate and it's correctly reject that it is an unknown user. because we only registered user 1 to 80, 81 to 100 were treated as an unregistered user, so we display as unknown. Okay, and for this case, 100 image went through the authentication or testing stage. Okay, we have actually 6 image was wrongly 8 misclassification result, where the true classes 40 was recognized as unknown, 54 as a basic, which is a wrong class, 81 to 98 should be the unknown, but they are only accept at the correct classes. Hence, in this 2 was the 40 and 50 was false rejected, so this FR is true. Okay, we have 80 true user, so the true acceptance should be 78. So 4 was falsely accepted, which is FA equal to 4. So total in also is 20, so this will be 16. Hence, accuracy will be 78 plus 16 divided by total 100 image, we get 0.94 or 94%. FAR is a false accepted rate, which is 4. Out of total, we have a 20 imposter, so it's 20%. False rejection, we got 2 out of 80, okay, which is 2.5%. True accepted rate, which is 78 over 80, 27.5%. True rejection rate, which is 16 over 20, which is 80%. Okay, so as a conclusion, transfer learning from AlexNet was applied on Dorsal campaign database, which consists of 100 users. Each user has 12 left-hand images collected under 4 conditions. The first 80 users were treated as genuine users and involved in training, while the remaining users were treated as imposter. Training data was divided to 80% training and 20% validation. The training and validation accuracy are obtained as 99.22% and 95%. The transfer learning net was exported to build an authentication system using MATLAB guide. 80 registered user and 20 unregistered user were used in the authentication system. The authentication accuracy obtained was calculated as 94%. These are some of the references uses, and we would like thanks the Ministry of Higher Education for financially supporting the work under FRTS Gracer Grant Scheme here. So with this, thank you for your attention.